So 3 of the 4 ways to represent vectors in 3D are Cartesian components. And so this is a picture of that, fx, fy, fz. And these guys add to f. And on your calculator, this looks like f is equal to fx, fy, fz. Coordinate direction angles are where the angles are measured directly from the x, y, and z axes to the f. And so from the x-axis to f is alpha. From the y-axis to f is beta. And from the z-axis to f is gamma. This page is in your notes. It's on the OneDrive. It's also on the course webpage for you to kind of practice drawing these so you can see it. And remember, the f vector then is equal to the f magnitude, and then the unit vector is cosine alpha, cosine beta, and cosine gamma. And this guy is the unit vector. So these are called coordinate direction angles or direction cosines. Again, the angles are measured from the force directly to the axis. Finally, there's spherical coordinates. And remember, you've got the projection of f. So you take f down to the plane, and then you have this guy, which is the f projection. And the angle in the xy plane is called theta. And strictly speaking, this is called probably phi. And we might call this guy psi. I think in my other notes I did it opposite. But in the official spherical coordinates, positive phi is measured down from the z. And positive theta is measured from x toward the y. And this is negative theta, this direction, negative theta. And so into your calculator, again, this is f vector is equal to an f magnitude, comma, angle, theta, comma, angle, phi. And that's how you enter directly into your calculator. So this page is in your notes or on the OneDrive. You should practice drawing these so you can draw them. Here's an example problem where you're given 2 vectors. We're given a vector f2, which is in terms of coordinate direction angles, and we're given an f1, which is in spherical coordinates. So we want to add these guys to get a resultant vector. And then we want to find the direction cosines of the resultant vector. So starting with that, we'll start with f2 because that's easier. So the unit vector for f2 is the cosine. This 60 is alpha, this 60 is beta, and this 135 is gamma. So the unit vector for f2 is cosine 60, and cosine 135. And so you get positive 0.5, positive 0.5, and negative 0.707. And you multiply that times 500, and you get your vector here. And on your calculator, what you would do is you basically would go on, and you would say control square bracket. I would go 0.5, comma, 0.5, comma, negative 0.707, enter. That's the unit vector times 400, times 500. And we get the 250, 250, and negative 353.5. So that's F2. F1 is given in spherical coordinates, But remember, our official spherical coordinates, positive theta, is measured this way. But we have 20 degrees in the negative direction from x. And so when I enter this guy in my calculator, this is 400 at minus 20, and then positive 60 down from the positive z. And so this is 60. So then I just go to enter that. I'm going to go control, square bracket, 400, comma, control, symbol, angle, minus 20, comma, control, symbol, angle, 60. Enter. And I get 325.5, negative 118.5, and 200. I can take this guy and add him to, I'll copy this other one. So this other one is too fish. I'm going to go Control C copy. And I'll go Control V paste here. And I'm going to hit enter. And so I'm going to add these two vectors, this one plus this one. And I get 575.5, 131.5, and minus 153.5. Just for kicks, we can find the norm of this guy. So I can go Control C copy, Control C copy. And then I can find norm. I can hit my catalog. Norm is already there. Enter, norm, Control V paste, enter. And the norm of this vector is basically 610 newtons of my FR. But the problem asked me to find the coordinate direction angles of FR. And so I need to find the unit vector for FR. So if you come back up here and get my FR, so my FR is this 575 guy. So I'm going to go Control C copy. And then we're going to come down here and I'm going to go to catalog. You go to U, and I'm looking for unit V for unit vector. And I'm going to hit enter. And I'm going to go Control V paste and paste in this vector here. Enter. And my unit vector for this guy is 0.9435, 0.2156, and negative 0.2516. So my FR is equal to the FR magnitude, which is 610, times this unit vector. But again, the problem asked me to find the alpha, beta, and gamma for FR. And so I'm going to take each term of the unit vector. And so cosine of alpha is equal to this. And so alpha is the inverse cosine of this, which is 19.4 degrees. Beta is the inverse cosine of this guy, which is 77.6 degrees. And gamma is the inverse cosine of this guy, which is 104.6 degrees. So with gamma being greater than 90, that means my FR is below the XY plane, which is kind of what you'd expect with this vector being larger than this one anyway. So this is an example problem dealing with a vector given in coordinate direction angles, a vector given in spherical coordinates, dealing with them, dealing with the vectors, adding them, and so on. You should be very facile in doing this. To be a great static student, you should be able to do this easily. And as you can see, doing it with your TI nSpire calculator or similar makes a huge difference. Huge difference. It's just faster. It's easier. You can enter the vectors just the way you're given. And so they're super easy.